This is Om Prakash Angappan from AV Academy. Today we are going to see the problems based on torsion. The torsion based problems we are going to see. In this, a hollow shaft is transmitted 300 kilowatt at 80 rpm if the shear stress is not to exceed 60 Newton per mm square and the internal dia of is 0.6 of the external dia. Find the external dia and internal dia assuming that the maximum torque is 1.4 times the mean. Okay, what they are asking is, first of all, given data, what they are asking is, there is a hollow shaft, it is transmitting a power of 300 kilowatt. We are just converting into watts, into 10 to the power 3 watt. Then it is in an rpm of 80 rpm. It is running in a speed of 80 rpm. They have given that the shear stress is not to exceed 60 Newton per mm square. 60 Newton per mm square. And they have given the internal diameter is 0.6 of the external diameter. That means dA equal to 0.6 of d naught. Then what they have given is, they have provided the maximum torque is 1.4 times of the mean torque, means T maximum is equal to 1.4 of T mean. Okay, and as the find the external dia and internal dia assuming that the maximum torque is 1.4 seen. That means to find I and D naught. Okay, solution. In this problem that we are going to take two formulas. First one is torque equal to P into 60 divided by 2 pi n, and as it is a hollow shaft, the other formula is T equal to pi by 16 tau into d naught power 4 minus di power 4 divided by d naught. Okay, these are the formulas that we are going to T mean. We are just going to substitute those values in this and we are going to find out the T mean. As already said, T power is 300 into 10 to the power 3, 300 into 10 to the power 3 into 60 divided by 2 into pi into n value is 80. From that we are going to calculate the value. T mean is equal to, it's taking the calculator, it's 300 into 10 to the power 3 into 60, it is 18 into 10 to the power 6 divided by, next 2 into pi into 80, the value is 502.65, means T mean is equal to 18 into 10 to the power 6 divided by the answer, it is 35.80 into 10 to the power 3 Newton watt, 35.80 into 10 to the power 3 Newton meter. What we are going to do is, we are again multiplying with 10 to the power 3 here, so the total value will be Newton mm into 10 to the power 3 Newton mm. Okay, just we are converting the Newton meter into Newton mm. Then T max is equal to 1.4 of T mean. The T mean value is 35809.86 into 10 to the power 3. Okay, when we are multiplying these two values, we are getting 50134.288.27 Newton mm. Then we have to substitute this. T max equal to pi by 16 into tau. The tau value is, it is not to exceed 60 into d naught power 4, d naught, that what, pi by 16 into 60 into d naught power 4 minus 0.6 into d naught power whole power 4 divided by d naught, means di value is di equal to 0.6 of d naught. So we are just substituting this 0.6 here in di value. So it is pi by 16 into 60 into d naught power 4 minus 0.6 power 4. We are getting 0.1296 d naught power 4 divided by d naught. Okay, then pi divided by 16 into 60 into 1 minus, it is 0.874 d naught power 4 divided by d naught. This d naught and d naught, it is to be d naught cube. Therefore T maximum equal to, the value is pi divide 16 into 60 into 0.8704 d naught cube. Okay, T maximum value is 50134,288.27 into 16. We are just bringing this 16 here and these values here down. Pi into 60 into 0.8704, we are keeping the d cube is in here itself. Then the overall value for this we will be finding out. It's 50134,288.27 into 16 divided by pi into 60 into 0.8704. The value is d naught cube is equal to 4.88916 into 10 to the power 6. D naught is equal to 4.88916 into 10 to the power 6 power 1 divided by 3. Then we are putting the power, 1 divided by 3. It is d naught value is 169.72, more or less is equal to 170 mm. We are taking d naught value equal to 170 mm. Substituting this d naught in di, therefore di equal to 0.6 d naught, di equal to 0.6 into 170, that means di equal to 101.83 mm implies 102 mm. di equal to 102 mm. Therefore result di equal to 102 mm and d naught is equal to 170 mm. Okay, we have found out the value for this. What they have asked is, there is a hollow shaft. Once again I am repeating, there is a hollow shaft. It transmits 300 kilowatt power at 80 rpm if the shear stress is not to exceed 60 newton per mm square and the internal diameter is 0.6 of the external dia. Find the external dia and internal dia assuming that the maximum torque is 1.4 time of the mean. What they ask, that we have found the result for the internal dia and the outer dia. Thank you.